Welcome everyone. Very nice of you to join me on this evening. We'll spend over an hour, maybe an hour and 15 minutes to talk about a couple of things that are related to instrumentation and modern practices in running your applications when they're written in .NET and maybe running on Azure. The things that I'll be sharing with you is the things I know about this instrumentation monitoring. And I encountered that in the real world, visiting many customers and talking to them with their practices and how they're doing things and advising them in this matter. So let's have a good time. Let's discuss. If you have any questions, like Tanya said, please feel free to share them in the chat, and I will answer them whenever I can. Okay. Now for the agenda, instead of having this bullet point agenda, I thought, okay, what are we going to talk about in this session? And I think the main thing is that if you are doing modern DevOps practices, which means you're building your application and you're running it as well, that you need to do monitoring. And we'll go into more details on where and when you do the monitoring. But it's an important thing. And Microsoft has this Devops checklist, and one of the parts is a DevOps monitoring checklist. So I've highlighted the first three. We'll be looking at those. The final one, the monitoring of assets and resources that they might expire, that's not the focus for this session. But it's how can you make sure that what you're running is actually that you can look at it and know stuff about it. How can you get all the log information and the metrics, that's the numbers that come from your system, how can you get them together and put them together? And finally also, how will you be able to know when things are going downhill or when things are bad? That's kind of what we're trying to find out. And making sure that your applications, when you build them, are actually capable of doing all of this, so you can do that as well. So back to the start. You want to do DevOps. There's a lot of that going on. In general, if you're a DevOps engineer, you're probably a multidisciplinary person. You can do a lot of things, from infrastructure to building code to troubleshooting. But in general, you do agile practices, and you have your work items that's part of the sprint, or maybe the bug items that surface there. And then you start working. So you start developing using Visual Studio Code, your tool of preference, and you enter your inner loop. So it's a quick feedback loop of trying things, getting information, and adjusting up until the point that you're like, okay, this is where my feature is complete. And normally, after you've done that in isolation, you're already observing your own system, but then you check into the code repository, and depending on your setup, you will get the test that will be run, test that will run as part of your continuous integration and continuous deployment. Mostly there's pipelines involved, and depending on stages and other things, eventually you'll end up into your host environment where you will be hosting your application. And this can be anything from a web application that is running in an app service. It might be IIS, it might be a Kubernetes cluster where you're doing container-based hosting. Could be anything, but quite often, once it's running in your production environment and you can't attach a debugger anymore and things don't behave like you want them to do, or maybe even things go bad, it's like this black box. You have no idea what is going on, and there's no way to look into your thing other than maybe some simple things, looking in the Azure portal and seeing if the Azure resource is up, but you actually have no clue. And this is what we want to change. So preparing things inside of your application, that it becomes observable, that you can look inside your application, and by that being able to close the loop. And the closing the loop means that you can look at your system, monitor, and look at the feedback that you can read from that. And it could be performance. How is it performing? Is it slow? Is it fast? Or what's the trend in performance? Do I release something new, and is the performance slowing down now? So maybe we released a feature that is not performance optimized. It could be that you want to see the rate of exceptions. It could be that you want to see what features people are using. So it's a metrics on usage of things. Is it a popular feature or not? That's how you observe, and that's what you need to get all the way back. So you need to gather all that instrumentation data, and then finally use some form of monitoring, so you can look at all that information, gather knowledge, and then decide on what to do. And that decision, it brings you back into the closing the outer loop. You as a team, as a DevOps engineer, you're also watching the monitoring information from dashboards or from inspecting the logs or looking at live metrics, could be anything. That's where you think, okay, this is a bug that I need to fix, or this is a feature that needs enhancement. And then you add a new work item. And now you have to pay close attention. There's a little arrow going down into the work items, because that's where we start all over again. New work item in your backlog, and you pick up the work. And this is kind of the thing that we why all this knowing what your system is doing is so important, because that gives you a healthy system, and that's also good for you, that you can sleep at night because you know that your system is doing okay. Well, now comes the thing with this application performance monitoring, and performance can be anything from what I said, how fast, how slow, how much memory, but mostly about is it performing well, and what is being used. But if you take a cloud application, mostly that's distributed in nature, in nature, and that means that there's different moving parts, and it becomes harder and harder to get all the pieces of information together and to bring them to a centralized place, or to look at it in a different way, but at least that you get overview. Because there's quite a lot of things. There's events happening, and well, we talked about most of these things, but there's also the logs and the health information of your system. And if you have 10 or 20 moving parts in your system, well, you need some additional tooling. And there's a variety of tools out there, some paid products, some more free than others. But this is what you will probably choose from. So one of these things will help you gather and look at all that information and provide you with the ability to look into your system if it's distributed. But it doesn't come for free. You can make it adapt to the situation of playing part in this entire distributed choreography across your system, and facilitating these systems to do a good job. Now, this session is focused on Azure, because the Azure, as an example, will show you what you can do. And in Azure, everything is nicely integrated, and it's a complete story. Doesn't mean that you need to use Azure. If you want to run in Google Cloud, or maybe in Amazon or Alibaba, that's all fine. If you want to use different tooling than the Azure tooling for monitoring, that's also fine. It's just that we can show things and look at things and how things work. But since from the survey at the beginning, a lot of you are running in Azure, so that's I think a good starting point. That Azure has this Azure Monitor. It was also in the previous slide. And Azure Monitor helps you to aggregate everything that is happening in your system. So it's centralized, and it's bringing it together so you can look at it. And the Azure Monitor is in two parts. That's the logs, that's record keeping with things that have happened. And there's metrics, which is a more volatile system where you can see graphs and trends of things, where logs are actual lines of things that have happened. If you then look at the way Azure is organized, and at the Azure tenant level, that's quite low. You will find that there's the Azure tenant is an Azure Active Directory, that those logs are pushed out into Azure Monitor. That's at that level. Then you have a higher level, that's the Azure subscriptions. And whenever something happens inside of a subscription, activity logs are also pushed to Azure Monitor. And then you have your individual Azure resources, which could be app services, virtual machines, Kubernetes clusters, or databases. they send diagnostics information to Azure Monitor. And it's usually a log analytics workspace. That's the thing under the covers. And you might have to tweak things so you're actually pointing to the same log analytics workspace, so everything does come together. But it's a matter of clicking it together or organizing your ARM templates when you provision things, so everything is hooked and tied together. Then on top of your Azure resources, obviously you'll have your cloud application running. Can be a variety of things, but in our case, we will look at .NET Core, .NET 5 at that level, where you will be using NuGet packages and other things like application insights to facilitate getting logs, traces, and metrics to also flow into Azure Monitor. And with that, you will get both at the control plane, where things happen from an administrative perspective, and at the data plane, which is your application running and things happening in your system on an application and functional level, will all go into Azure Monitor. And by bringing that all together, you get a total overview of administering and running your application. This will be our main focus because we're mostly developers. The other things are also important, but they require less coding because those things will just be there, and you can influence more at the code level. Now, what does it mean to instrument your application? The way I look at it is there's a couple of things. First of all, there's the obvious one, that's logging. You want to log information. Then there's one that's closely related, that's tracing. And we'll talk about the main differences in a moment. Then you have your metrics, which is something like numbers, statistics, and you have health information. And health is a little bit different than the other ones. For all of these, there's a variety of NuGet packages that are either .NET Standard or .NET Core or .NET 5 based. And they will allow you to interact with the logging, tracing, metrics, and health information systems inside of your application. And these individual parts, the logging, tracing, and metrics, they will all be collected because they are pushed out and they need to be collected by something that stores it and correlates and aggregates it. So that's going out. It's being sent from your application to some destination, which is when you are able to collect it, you can send it to your monitor. The health information is a little bit different because the health information is being asked to provide something. So that's the top one is you can consider it as a push model. The bottom one is more of a pull model. You're pulling the health information and you're exposing it on demand, whereas the top things are just happening anyway. And that's why it's all different. But the net result is that your monitoring system is getting all this information from your application, and your applications can correlate it because if that's being taken care of in your applications and your distributed system, and then you're good to go and do all this cool stuff with analytics, alerting, creating dashboards with red or green lights so you can see what is happening in a blink of an eye. The alerting will help you get notified and raise attention of things that are happening. And with the profiling, you can see performance kind of things. And with metric stream, you could go into a whole other things of sending out metrics and making everything real-time observable. That's all possible. There were a couple of arrows on the left-hand side here and there. There are ways of having your log information surface as tracing and tracing information surface as logging. And you can get your health information to be collected as a form of metrics. That's all possible. Sometimes you want to do it, but especially mixing logging and tracing, while tempting, you might want to have a clear distinction of the differences between logging and tracing. And we will definitely get there. Now, what happens every now and again is that things get mixed because they are closely related. But I find that if you do things fit for purpose, so use the things what they're intended for, then you have a clean system, and then it's a matter of combining things, but use things for what they were meant for, such as the logs. And I think most of you are mostly familiar with logging. Logging is about persisting what has happened in usually human readable text for errors, warnings, or other important things that you think, I want to read that back, maybe up to a year or 2 years ago. That's log retention, usually a long time. And things are always logged, so they're always persisted, and you can still tweak and tune that, but it's what has happened. The tracing, however, is more, you want to see the flow of your application, how things happened, in what order. It's usually much more verbose, so a lot of information. And because you don't always want to know that, it's mostly for diagnostics that you want to see, okay, things are going slow or bad, or the logic doesn't seem to execute. Then you want to see the trace inside your application, the trace across your applications, the various distributed parts. And because that's noisy, a lot of information, they have a publish-subscribe model where things are only observed when there's a subscriber. It's being published, but if nobody is subscribed, it will just go away. And if there are subscribers, it's their task to hold on to that information, but mostly not years of storage. It's usually 24 hours a week maybe, and then it just flushes out because it's not that important. That's what you need to do. If that's the case, then you need to do logging. Now the metrics is how much, that's numbers, that's averages, that's maximum, minimum values of things, and that's for seeing trends of the things happening in your system. Think about the average number of items in a shopping basket. That could be a metric. A metric could also be more about your system, the number of web requests coming in, the memory usage. That's other types of metrics that are more about your system running. And you have the functional or the business metrics, important things in your system. The health is about how are you doing, the system determining by itself, I'm healthy or I'm not. And we'll talk about health monitoring later on as well. And then you have the auditing, that's more about the who, to make sure that afterwards you can see who did things. So auditing is much like logging, but it's about critical events like a login of a user, or maybe an important delete action that's being executed. Who did it? Because that's what you need for the non-reputability attacks that might happen. You can read up if you do the stride analysis in the security and the threat analysis. That's where you do those kind of things. So let's dig into logging for a bit in .NET 5, but most of the story that is here is also applicable to .NET Core, mostly around version 2 later and later. But I'll try to, because that was one of the questions, what are the differences with .NET 5? Not that many, but I'll point out one or two of the things that have changed in .NET 5. The logging, there's a number of important concepts that you need to be aware of. First of all, there's things happening, and you capture what is happening with a log message. And a log message has a category because it relates to something. It's in a certain area, and it has a level. That's how important it is. Think about your mail messages. You can add important or low priority or a regular message. Well, there's levels for that. And then you have a logging framework, because your application needs to be able to send out those log messages. And you will add one or more log providers on the other end. So your messages end up somewhere. And it's a provider pattern, and the log providers, what they provide is they don't provide the log messages. No, they provide a log. That's where sometimes it's called a log sync. But it's where the log messages end up. And then you have your filters, because depending on the log provider, you might want to see more of the log messages or less. So that's mostly based on category level that you do a certain filtering. The logging providers, if you start using that, and we will dig into some more code later on, and I'll point out some interesting things. But the logging providers that you want to use, you need to register them at startup. And since .NET Core 2.2, I believe, there's a new way to do the configuration of logging providers. It used to be in your startup class that is used for the web host the defaults. There you would do the config method, and you would register things inside of a logging factory. Not so much anymore. It's now inside of your program CS file. If you open it up, you see that your main method is calling this the create the host, and the host will do most of the time a method to help you create default builder, and then configure various parts from the configure the configuration, configure the logging, and other things that you want to do, like the web host defaults. The configure logging is where you will use a Lambda function to register your log providers. And depending on what you want to do, you can add on top of what is added in the create default builder automatically. Those are three things: the console logger, the debug logger, and the event source logger. You'll get those for free, but if you don't want to have them, you can say builder clear providers, they're gone, and then you build your own list. Or you can add to them as you see here. So we're adding App Insights, we're adding a console thing. And this part here, I might point out, has changed a little bit. The add console in .NET 5, this is deprecated, and there's a new way which I'll show you in the demo. There's other log providers from ASP.NET Core that are closely related to the fact that if you have a web application, a web API, that you're probably running somewhere in the vicinity of an Azure that you're hosting there, or that you're using App Insights. And App Insights is also a topic that we'll cover later on. And there's third-party ones that if you use the built-in system by .NET Core and .NET 5, you can put this way of logging, you can stream that into other logging systems such as Log4net, and Logger. There's ways of redirecting it so you can make things work together. Now, the logger factory is the place where you would, during the startup, if you do the builder, you're actually building the definition of your logger factory, and you register a couple of providers. That's the startup that we just saw. And then whenever you want to use a actual logger, you're asking for an iLogger implementation. And there's a derived type, iLogger of T, with a generic that has some benefits of using. But each time a logger instance is created, you'll get all of the logger providers attached to it. The way you normally get a logger is by injecting this abstracted type, iLogger, into the constructor of your controller, or in other places where you can look into the dependency system and ask for a registered service. And your iLogger is registered automatically by the plumbing, and the logger factory is used beneath the covers to produce an instance of your logger. The iLogger implementation has a couple of log methods, and the log methods represent the level at which you want to log. And remember, there were two things about the log message. Obviously, there's what the message is about, but there was a category and a log level. And this is how you can easily provide the correct log level by just using the appropriate log method. Now, the severity level, the levels of the logs are listed to the right. The important ones are debug, information, warning, error, critical, 1 through 5, and those are getting more and more important. Critical is, you know, that your system is going to crash. It may be beyond crashing, and it's one of the last things that you could log, a critical error, out of memory exception, or whatever, and that's the final thing that you want to log. And then from error and above, it gets less and less severe. Now, that's the level side of things. And then the categories are like a hierarchical structure. They are organized into dot-separated deeper nesting. much like namespaces. And if you create this iLogger of T, what will happen is that if you have your class called leaderboard controller and you ask for a iLogger of leaderboard controller, the log category will automatically be the fully qualified type name of your T. And in this case, it's leaderboard controller inside the namespace web API controller. So it's the full thing, that's your category. And that will help you with filtering, because then you can say, I only want to receive messages from controllers. And then you would put a filter on leaderboard web API.controllers.star. And then the star means everything from that point on. And then the star you don't have to mention, but you can just tweak that from a certain level. That's the log filters that you will apply. And in your app settings, you're able to specify for each of those providers what the various levels are that you want to listen to. It's like a volume knob. If you turn down the volume, you will only hear the most important ones, like critical error warning. But if you go beyond that and turn up the volume to information or even debug, you will get more and more log information. Otherwise, it will be discarded. Now, this is a part of the app settings JSON. This is the generic part. That's without regard of the specific provider. And you see that for various categories that we are specifying different levels. So the default is information. But if it's a log inside of the category of Microsoft, we want warning. But for the hosting lifetime, it's information. That's one way of doing it across the board for all registered providers. And for individual ones, you can specify the registered name of your log provider, for example, console, and then you can do the log level thing that is here. You can specify like here, but then specifically for the console logger. The other things are the options that you can set for this particular provider. And that's how you can do a generic thing, like, okay, I want to hear only warning because that's the default, but for this particular provider, I want to have something else. Now, I'll go through an application I prepared for this session. I instrumented it in a couple of places, and I want to highlight a couple of points there. Let me see what we can do. So here we are. This is an application that consists of two parts, a web application and a web API. And it's .NET 5 that we're using here. The web API is calling behind the scenes. So on the server side, it's calling a web API, and the web API is calling a database. And the application looks a little bit like this. So I'll start it so we can hopefully see the application working. And if it's not working, then, well, we should be able to see some monitoring information and then see what's happening. But for now, let's just keep our fingers crossed and see if this is actually running. So to illustrate, I'm running this from a Docker composition because I want to have not just these two applications, but I also want to run the database. I want to run some logging providers and various other things so I can inspect my system running locally. So this is for the local setup. This is the web API, just a little demo. It's about leaderboards of video games. So if we give with okay, we want to see what the list of the leaderboard is. And if we execute that, then we can see that we get some XML, or if we provide JSON as the content type negotiation, then this will be JSON, but it's high scores for video games, Pac-Man and Space Invaders. And if we go to the front end, then the front end will be calling, it's a Razor page, and the front end will be calling the back end, and it will get the same information there. And this can be a long list, and this is just a preceded demo information. And my database is running as a container image as well. And it's a SQL Server database, which allows for easy transportability into Azure SQL if you go into production. Okay, now showing parts of the logging information. let's have a look at the startup of things. This is inside the web API. And the web API, as you can see, the main method calls this method create host builder, which is the default. This method is worth investigating, because if you look at the metadata, it will describe what it's actually doing, all the things that are being configured, and also this iLogger factory that specifies that it's pre-rigged to log to the console, debug, and event source. So the console means if you're running inside of a console application. Debug means when you're in a debug session, it will put that into the output window right here. And the event source is for Windows, with event tracing for Windows and the new systems surrounding that. Now that is happening all automatically. And in our case, we do some configure of the logging, and we add application insights. We'll get into that later. I added something different as a log provider, sec, as a queue. And this part is what is different, that instead of add console, they now have add simple console. And that is new in .NET 5. And the way you configured it is also different. It now has different ways of setting a couple of properties, such as don't do any color logging, because you get the weird color codes inside of your output. You can switch that off, and you can log to a console window. That's kind of the bootstrapping, and from there on in, it's fairly easy to start using it, because in a controller, what you will typically do is you will either use the logger factory and have that injected into your controller class. That's where most of the things are happening. And you can create a logger from that with calling create logger of T. And in this case, it's mostly this leaderboard controller. You put it there, and it predefines your category. But if you just do create logger, you can specify as a string the category that you want to log to. This is stored inside of this logger variable, which makes it very easy to substitute this during unit testing. And then the only thing that you have to do is you can use each of the methods. And just for demonstration purposes, I've done them 3 of them. You can choose, if it's configured, log error, log warning, log information. And the Elvis operator here makes sure that if for some reason it's not registered or not injected, it's a null reference, you don't crash your code by logging. But that would be bad, that your logging will actually crash your application. But it should be there, and it should be available. All right, so that's one thing of using. And then there's one part where you're like, okay, but what if I want to log more during startup? Now, it's kind of difficult to log during startup, but it is very well possible. And do know that if you go into your configure method in the startup class, that you can already inject an iLogger. And this is the other way of registering or injecting a logger instance, not through the factory, but with the concrete instance of iLogger of your type. And with, in this case, it's during the startup, and then you can do logger log information from this point on. And you don't have to do weird stuff to explicitly use the dependency injection system to ask for a service, and then you can just have it injected in this method here. This is where you can use everything that you've pre-configured in the configure services method. Yes, we'll look at other stuff later on, but now we're up to the point. This is probably what you already knew, some .NET Core and .NET 5 specifics. Now let's take this a step further, and one of the important things that if you want to get the most out of your logging information, I think is that you're using a little bit of the quantum physics thinking. I studied physics. I'm actually a technical physicist when I went to school, and what they taught me there is that from a quantum statistics perspective, there's quantum state which can be up or down, and it's both. It's up and down, Just like in the example, the thought experiment with the cat inside of a box, you can't look into it. There's poison there. It might have been released. It might not have been released. So the cat is both alive and dead. So it's half dead, half alive. It's only when you observe that it's either one. So if you open the box, then you will notice the cat is alive or he ate the poison and he's dead. And I thought it was a nice metaphor into the logging system, that there's a duality. On one side, you want to have these human readable pieces of text, and we'll talk about a function, the retrieving all the high scores where there's a parameter called search limits, and we want to log. There was a search with a limit of 10. Text for a human, very readable, very good. That's one side. But it's not very useful if you want to talk about, okay, there's a couple of places in our system where we talk about a search limit. Give me all the log messages with a search limit bigger than 10. And then you're like, okay, but I need to parse all of the log messages. And if the log messages are different descriptions, I need to use regular expressions and I always need to get at the number, and I need to know where the number is. But actually, I just want to know what is the data that is in there, the relevant data, and that's the machine contextual data, and that's raw data, and it can be either one or both, and this is what they call semantic logging, that you can have either one. You have a log message with relevant data. You can watch it as a text string, or you can look at the data as well, depending on what you want to do. Semantic logging, also known as structured logging, and it's easy to use. The only thing that you need to do differently is that inside of your log message, you will be using a template. And this is not a formatted string, as you can see. This is not string.format. Otherwise, this would have been 0. There's no $sign in front of it, so it has the other type of placeholders. This is just a positional placeholder with a name, and this name is relevant. This is where you need to give it some thought. What are good terms? Because this will surface as the metadata. In this message template, there's a part that says search limit, and it has a value, and the value is located at the end. If you want to have more of those placeholders, it's just positional. So it's 1, 2, 3, and at the end there's 1, 2, 3. Arguments that follow afterwards. And by doing that, you can have this readable string where the limit is actually put into place in the placeholder that's reading it, but it's also extracting search limits from log messages. And as far as I know, there's only 2 that can really deal with storing this type of information, and that's SAQ and that's Application Insights. And I will show in both cases how that will surface in your application and inside of your logging system. All right, let's do that. Because we already saw in the controller here that we were doing this exact same code with the search limit. This will happen if we don't provide any information. It's a 10, but the user interface will give that information, and we can also trigger it. Let's go back here and go to our Swagger. Go here, and we execute this, and we will say, okay, let's do a limit of 7, just an arbitrary number, and we execute this, and we get the 2 results. But now, since I have this SAQ running, here we have a container that has SAQ. It has 2 ports, port 80 and port 54341. This part inside of the container is where you will send the messages. This one is for the web interface, and I'm exposing the web interface at the ingest port of the thing, but this is a port recognizable as something that belongs to SEC. What it means is that if I go to my browser again, and I go to localhost 5341, I enter the SAQ. This is running in a container, and I get all this log information here. And it's a lot of log information. Everything ends up here. But if we are lucky, we can do search limits equals 7. what we can see now is that there would a log error, log warning, log information. This is how that surfaces. And this is looking at one side of the information. This is the textual part where you, okay, this is, apparently it's about 7. 7 is important. If you click that, you can see that there's also this metadata that also says 7. That's why we could do this. Just search limit equals 7, and it searches across all log messages and filters out, based on this thing here, it filters out the ones that have 7. And you can do other things like, sorry, I locked my, I have a keyboard with a lock thing there, so I locked out myself. But anyway, I was going to say bigger than 5, for example, and you can see that you can search across these things in a symbolic way using the metadata. And the more you instrument this, the better, richer queries you can have. Yeah, sorry about that. I accidentally locked the computer and it stopped sharing. What I showed in the final part was with the search limits as a symbol inside of your log messages, you can do queries where you actually do like bigger than or not equal to or and operators with multiple of those things, and you can go through your log messages and not just have this one, but any log message that also has a placeholder with search limits, and that gives you very rich way to search across all of your logs. Okay, the reason that it ended up here, we skimmed over that, is that we added it as one of the log providers, and this is internally inside of the container name with the port number. But that's all it took to send that information to SAQ, and SAQ knows how to deal with this log information in a semantic or structured way. App Insights does the same thing, so that also stores both the text and the metadata. Back to the slides. I'll be brief about scopes, but there's more things to it when you start logging. Sometimes you want to group a couple of operations together, and then you need to use scopes, and you use this thing called a begin scope, and everything that is inside of the scope will be logically grouped together based on the message that you give to the scope. So you will resurface the scope description every time something is logged. But you need to include it as one of the options when registering your provider. And that means that you do include scopes equals true. It's not set to true by default because it introduces overhead, and it's a deliberate choice to do that. Now we're up to the point that, okay, so please do structured logging because that will give you much richer information. Also, don't concern yourself with where it goes. Your application shouldn't do that. It registers the log providers, and whether it ends up there is configuration. The severity and the categories are determined outside of your application. That brings us to the severity level. And let me just quickly show you a bit of logging that is in there, and give you a small well, a little thing to think about. So here I'm calling from a proxy. This is the web page that shows the high score. It calls into the web API with the method get high scores. That's inside of a try catch block, and we're neatly catching and at a higher level as well. We're catching all these exceptions. Catch. These are all the things that can happen. What do you think would be the best way to log this? Because there's an error happening, so how should you log? Should you use information or debug? Or maybe you should log error because there apparently was an exception, which is an error. This brings us to the fact that this is not very smart to do, because if your application starts saying there's errors here, there's something really, really wrong with your system, because there's errors and there's just one level higher. That's critical. So this will raise flags. Your dashboards will go red. because you actually caught the exception. So how important is it? It might be an unknown exception, and it could be a reason that you still do log error, but it might be just warning or information, so you can inspect it. But the system is not crashing; it's handling these exceptions nicely. Choose your log level carefully. Well, I think that's most of the guidance. You can use event IDs if you feel a need to tag them with a certain number, because event IDs are numbers that make it also traceable. Do know that your log messages don't have to be pretty, and don't show them in your user interface. There's no need to localize them, because they don't end up there. They can be your own language. And if you are not sure, it's better to overdo the logging. Your filters will take care of it. And but do take care of not going into the tracing part, because tracing is something different. If you feel like you're logging all over the place just because you want to know what the flow is, you're not talking about logging, you're talking about tracing. There's other logging solutions, Log4net, Nlog, Serilog. You can pick whichever one you want. I think the built-in system is pretty good. The reason to switch could be because the rest of your application, legacy code, or you just made a choice for a different one, is good to replace what is there. That's definitely an option. Serilog has a very large number of providers that also span outside of the Microsoft ecosystem. You might find that your particular log provider is available for Serilog and not for the .NET side of things. But usually you're pretty okay with the built-in system. Now let's move into tracing. Tracing is about doing diagnostics when things go bad. And if you want to look inside of your system, it's like measuring on a motherboard. You put the multimeter pins on there and you start measuring what is going on, where is the error. And this is what tracing is about. It's publish, subscribe. You only do that when it's necessary. You attach a listener, which is the subscriber side. And you start monitoring the information and sending it out. If you're not listening like before, if there's no subscription, the information that is published ends up nowhere, and that's totally fine. It is a choice to add this to your build or not, because trace and trace source entry points are only available or effective if you compile with the compilation constant trace. And that is what you need to set in your project properties. So the compiler will compile with the trace flag, which makes sure that the trace thing actually does something. And under the covers, it's using activities, and we'll talk about that in a second. There's two sides. There's the traditional trace class. It's a static class. It gives you a singleton, and that allows you to do, well, let's say, more the log style of tracing. It has the same levels like error warning information or just simple write statements, as you would maybe do with console.write if you want to output something and just write something so we can look at it. This might help you during debug sessions if you instrumented your application with this tracing information. The newer one is the trace source. That's why you can have multiple instances. You need to create an instance of trace source. It can also have the listeners, but the way you send out information there is more semantic, because you trace data or you trace an event, and it's meaningful and it's typed. That brings you sort of like on the where you have the semantic logging. This is more like semantic tracing on the right-hand side. Both of them have switches. You switches that allow you to turn things on and off, or maybe a certain level of when things go into the tracing system. But this is high volume, and this is about following the flow of your application. Under the covers, it leans on something called activities. And activities are, well, something magnificent. It's really good that it's in .NET Core. It allows you to start an activity from a particular point in your code. And that activity says, okay, now we're starting something. And you can see it, the example here, it says a search engine.run. Let's say that's your activity. We're running a search engine. It's a complex object model, and I'm starting to call all these other classes there because I have a rich object model and all these design patterns, and I'm just calling. I'm doing multi-threading, and everything is going everywhere. But still, I want to know what happens as part of this running the search engine. When I call that method, the search engine goes and it does stuff, and I want to collect everything together and know in what order what happens. Now, this is a typical example for tracing. This is where you don't want to use logging for two reasons. It's not about logging. You don't want to persist that forever because there might be millions of calculations running inside of your search engine. Do you really want to have that pollute your log? Probably not. And also, if you want to do logging, you need to inject a logger instance into each of the objects that you're using. And if you're using all these business rules and all these small objects inside of your search engine, you need to inject that everywhere or pass it around in your method signatures, and that's not really pretty. And the activities have these ambient contextual data with activity.current, and wherever you ask for activity current, it will give you the same activity or a new one, but related to the parent. And that's why everything is coming together. It uses the W3C tracing format. So this even works across network calls to the other side. The other side needs to be aware of this and pick this up, but that's something where application insights can help you, or other monitor tooling that look at the W3C tracing. Now there's a whole bunch of trace listeners. These are the ones that came with .NET Core. That's mostly the top part here, where you have the default trace listener and text writer based things that go to the event log or as XML or to your console. There's a couple of ones that are in the .NET framework, if you might be using that. But you can see that it's system web with IIS, not as common anymore. And web pages refers to ASP.NET Web Forms, which is not part of .NET Core anymore. And also here there's Visual Basic Logging, where you can see that these are more the old ones, and the top ones are the new ones. And there's different NuGet packages for additional trace listeners that come with other products or other resources. Okay, let's have a look at the tracing. And I'll highlight a couple of things to show you what is happening here and there. Let me see. If we go to the startup of our web application, we also have the logging system. But now here I'm registering these trace listeners. And this is the left-hand side of the one slide, the old version, where you can do trace.write, trace information, for example. And you register all your listeners by doing this. And this will give you the ability to use the trace somewhere in your code. And let's see if we can find something here. Yes, here I have a little thing. This is quite neat, actually. When calling from the front end to the web API, we're registering a typed client, an HTTP client. It has some options with the address, and it has a policy. And the policy is doing a timeout. So we're timing out after about second and a half here, 1500 milliseconds. We're doing a timeout policy to terminate the call from the front end to the web API if it takes too long. And we're wrapping it inside of a retry policy, which says, okay, whenever there's a 500 error or a 408, or it got terminated because it took too long, you can retry 3 times. And whenever that happens on the retry, we do this trace information, and we're just outputting this, not as a log, because this is just saying, okay, we retried so many times. But this is the way of low-level trace information, where you can actually see in your tracing output, in the various listeners that are there, hey, there's something going wrong. And I'll demonstrate this, how this works. We'll go back to our web application. We'll enter the front end, and this is going pretty fast. It gives the high scores, but there's a bug in the system that if I do a limit of 0, it actually breaks. And the front end doesn't really mind because it terminates things. But here you can see that we're retrying now, and I'll get rid of the breakpoint, but we see that it's executing. And then after 3 retries, it will do it doesn't show the high scores anymore, but things happened under the cover and inside of our output, because we registered this console thing inside of the output. And I might just be able to show this better inside of the container stream. So there we go. Make this a bit bigger. In the gaming web app, you can see that we have this information that's being logged. It's of level information. This is the unique identifier that we have, and this is where it says retry 1, retry 2, retry 3. And it's ending up here because of the simple console debugger, that it ends up in the logs, the textual logs of the container. This is where you can see, okay, so we're retrying, and then you have the final timeout, and this is just part of regular output. Very neat, very clean, and you don't have to inject any log providers, because this is normally what you're not interested in, having this in your logs. Okay, moving on. So far, we've done a lot of things to output information, and we're sending out log information, trace information, and the outside system has to determine what it actually means. Is this a bad thing? Is this a good thing? Response times might be slower, but if you look at it from the inside, then you will probably have a good understanding of how your service, your web application operates, and what it means that there's a buffer running high, or memory load is increasing, or CPU usage is going high. So you mostly know best what it means when your application or your service is still healthy and when it's not healthy, instead of having to determine it from the outside. Now that's where the ASP.NET Core health monitoring comes in. It's as simple as registering this service for the health checks. This is what you do inside of your startup, configure services, you do services, add health checks. That gives you a default health check service in the dependency injection system. And the other thing that you need to do is do some routing to an HTTP endpoint. So you get this health endpoint, and you can choose the name, but mostly you will pick something like health, or health Z is also used. Then if you ask, are you there, then the normal implementation will be we do an HTTP get on the health endpoint, and we immediately get back at 200 OK, indicating I'm there. But the only thing that you can measure from that is you're there. This is how long it took, so you're slow or fast, but that's it. If the application is down or unreachable, you will get no answer. So it's either you hear that it's there and it's alive, or no answer, not a good thing, but no detailed information. And that's where health checks come in, where you actually start checking what determines your health. There's a couple of ways of defining a health check. There's local ones with simple things that you can do synchronous and asynchronous lambda expressions. Mostly you will do this implementation of an health check interface for a particular type of check. And in this case, there's a check to a SQL Server database. Is it reachable? Can we do a connection to the database? And another one could be, is my URL endpoint reachable? Could be your web API, or could be a CDN network that you're relying on. Now, whenever somebody sends a GET to your health endpoint, what happens is that the health report is being built, and we start evaluating each of the health checks that were registered. So the synchronous one will block, but sometimes that's what you need to do. Then you have the async one, and assuming that they all say it's good, your health report will stay indicating that we're in the green, we're healthy. But let's say your SQL Server is responding slow. Then the health check might say, okay, it's not that bad. It's not unhealthy because I can reach it, but it's slow, so it's degraded. It's not as good as it should be. And it can also be an indication that you're running a higher temperature if you think about your own health. So, don't have fever yet, but you have a raised temperature. And then if something is unreachable, for example, that might be a reason to say, okay, this is bad, this is unhealthy, I can't operate anymore. I might not crash, but this is not good. I can't perform at all. And then your health report turns red, and the net result, instead of sending a 200 okay, will be a 500 not okay with details. And the details is your choice. Either you don't send them out. It could be like inner details that you don't want to expose. But if you're in a trusted subsystem, your details might give the other side a clue on what is actually happening. And in this case, it could be the details of the health report saying the URL failed, SQL was not so good, the rest was okay. Now, there's again here. This is the push. The pull model. You need to ask at the endpoint. The other way is also possible. That's where the health check publishers come in, where it's being pushed out, and that's in the form of metrics that can be collected. Same thing. You do add health checks, but you also want to have this health check publisher. And you can register the various publishers by doing add and then this particular registration for your type. The add application insights, there's Datadog, and there's Prometheus. The Prometheus one is, there's a new way of doing that, but in general, you're pushing it out again, like in a push model. The publisher will publish it to another location, and that's the other flow. This way, you don't need to expose an endpoint, and you can do it to a well-determined place where things are being pushed. During this happens periodically, like a heartbeat. Whenever the health check publisher says, "Okay, this is your period that you want to do it every 10 minutes or so," it will do the same thing. It will ask the health check service to build a report. And with that report, it will send out to all registered health check publishers. It will send out the information and push them out. And each of them does a different way. Prometheus has a special metrics format, and App Insight will just surface it inside of the App Insight system. This will help you with other things if you have those health endpoints in place. It will help you do readiness and liveliness, for example, because your application is able to tell if it's ready to receive traffic. If it's not, then a cluster environment like Kubernetes will make sure that if your application is starting up, you're checking all your dependencies. Wait, this is not ready yet. I'm not ready yet. I'm preloading my cache, for example. And then once you're good to go, then you will give the thumbs up, and then it's okay. Routing traffic, and then you're in business as a container instance inside of a pod. During operation, the Kubernetes will periodically check your liveliness. Are you still okay? And it's a very harsh world inside of a container cluster, because as soon as you start saying I feel well, you're being dismissed. Go take a rest. Down goes the container, and they up a new pod with a new container, and hope that it will will help in resolving the issue that was there. Doesn't always help, because if the database is down, you can restart your container how often you want, but it will keep restarting. That's why you want to do all these delays in a proper way, so you don't flood your system with restarting all the time just because your database was out. Now, I'll skip over these things. There are some details here on how you can register those. Suffice to say that you can tag them, and when you register multiple endpoints, you can say, okay, run these tests with a certain tag or not. And that's how you can switch between certain tests for ready and lively when you have multiple tests registered. Okay, let's have a look at that. And I'll show some additional things, how you can really look at that. Inside of the information here, let's go here, startup. Here we have some health checks. The web API is depending on a database. So we have this first line to register everything with health monitoring. That's the first part. And then we're saying, okay, check the database. And I can specify connection strings and everything. But my leaderboard context is already pre-configured as a DB context from Entity Framework. So I can add a health check that uses DB context for the information. I'm giving it a name that is easy to recognize, the database. It could be different ones. So it could be the leaderboard database. You can be more specific. And you can tag them for the readiness and the liveliness. So I want to check this when before, and it needs to be okay before I am getting ready. Another thing that is used inside of this the web API is that all secrets are stored in an Azure Key Vault. And so we're adding a check to the key if the Key Vault is available. And specifically, we're looking for these things, and I've added two just to show, but it could be certificates as well, or this key. And in this case, the retro key and the application insights instrumentation key are stored inside the Key Vault. It will check, is the Key Vault reachable, and are these secrets and keys that I registered here in the options, are they also available? And I'll show you what happens if they are not. So with this, things are pretty okay. In my Docker Compose, let me show you one thing more, that in the startup at the bottom, let me see, this is the wrong one. In this startup, we're registering some endpoints here. This ping endpoint that doesn't do any evaluation of the health checks, the two that we have. There's the ready endpoint that filters by the tag ready and writes out a response with JSON format, only reachable through a management port. So we keep it secure inside of our cluster or in our Docker composition. And we have the lively that evaluates everything. So true for all checks. Also only reachable through a management port, which is configured to be 8080. I believe that's somewhere in our composition file that we have the ASP.NET Core management port at 8080. So that's unreachable from the outside, only reachable inside, because as you can see here, it's not exposed outside of our container. Well, a lot of things. The Key Vault name is a guessable name, so that's not really a secret. That's where the Key Vault is, but you need credentials to get in there. This connection string is for testing purposes on your local machine. It's not the external one that might also be configured, and that's the one that could be running inside of Azure. To be able to look at those things, let's see. We can. Not sure if everything is exposed, but let's try for our endpoint here. Let's see if we can ping it. We can see it gives this text healthy, which is good. It doesn't evaluate any health checks, so it will always be healthy. And if we do health, then we get no point at all, because that's not exposed. So we can't look at it. But we do want to look at it. And the way you can construct that for debugging or testing purposes is that you can have a container running and a container that runs this health check UI. And because this is inside of the container cluster, it can inspect the endpoints. So it will look at the two endpoints for ready and lively, and it will run all the checks there. And this one is reachable by 5,000. Again, this is for testing purposes only. If we go to 5,000, is it application running? It is, let me think. Oh, yes, all right, I know. We need to specify this health checks UI. There we go. And you see that this provides a nice user interface. The readiness checks, if you open it up, you can see that the database ones is there because it's tagged with ready. And this one also has the Azure Key Vault there because it doesn't filter on any of the tags. Now let's see if we go into the Azure portal. right here, and we go to our Key Vault, we should see that there's a secret for application insights. That's the instrumentation key. And we also have the key retro key. And those were being evaluated as part of this being healthy. If we go to this retro key and we delete it, and we say yes, deleting retro key, let's go back. And already, without refreshing, it does it every 10 seconds, as you can see here. And you can tweak that if you want to. But already you can see that it's reporting unhealthy because the key was not found. And that gives the net result that this liveliness check, it's not okay anymore. The same could happen if we drop down the database, then it can't reach the database anymore, and it will also light up. And this information is now available as from the health check endpoints internally. But you can also send it out as metrics information to Prometheus or to application insights if you wanted to. This gives you the application itself reporting if it's doing okay, and you can deploy this as part of your application. Now, final part is about application insights, where we bring the monitoring tooling, the application performance monitoring, and make everything work together. This is the part at the bottom where we have application insights, gathering a lot of stuff and providing it as a source for Azure Monitor. Now, the good thing about application insights is that if your application consists of Azure resources, web applications, and it can be Angular or React based or just plain HTML pages like I have, you have web APIs, you have other dependencies. From each of those parts where you're instrumenting and using application insights, if it's the front end, the web API, or at the back, everything gets collected into application insights. And that allows you to correlate and trace all across the board, because it does tracing as well, correlating flows of application parts together. There's not much you need to do because we have most of the things in place. If you're doing logging and tracing, there's this, if you register your log provider as an application insights, then it's as simple as that. And your logging information also goes to application insights. If you use tracing and you want to monitor that inside of App Insights, it's adding a trace listener. And if you want to do special stuff yourself, like events of important things happening, then you can do telemetry with the telemetry client. And important to know is that if you are working as a developer, set the developer mode to true, so it's immediately pushed out into application insights without being buffered too much. And application insights still has some lead time. It's not instantaneous, but in some cases, it's pretty close to real time. Okay. Let's have a look at our application, because it had 3 moving parts, but maybe more, if we can see what is going on in our application. So the instrumentation that I did in the various places is we had this application insights trace listener. We have a configuration in the startup of our telemetry, where we're adding a singleton with a telemetry initializer implementation, a class that we build, a service name initializer, and I'll show you that because it's fairly simple, but it's about giving pretty names to your telemetry client. So in your in App Insights, in the Azure portal, you can read this name, and you can do other things as well during initialization, but giving this role name is usually good for going to readable names. We're adding the telemetry, reading it from configuration. That's where you need your instrumentation key, and the instrumentation key is used to have an endpoint in Azure to send all the information to. The same thing is done for the web API, and I'll show a couple of special things later on, but that's most of what you need, because as soon as you start using it, there's so much taken care of for you that you get a lot of things for free. And I'll show you the Azure portal again, and we'll go to the application insights resource. This is the one that we're using, and this is where you'll get information. This is a little more of the dashboard part, but you can also look at the live metrics. Let's have a look there. If this is happening and you're good, it will give you information. If we go to our application now, let's go back here and go to 44325, like so. This is good. Let's run this again, run it a couple of times, triggering a couple of requests, and we'll create some errors with the bug that was in there with the limit is 0, and doing that a couple of times as well. So we get some errors there. It takes a couple of 3 retries, 4.5 seconds, 3 times 1.5, and then we get this empty page. And here you can see all this telemetry coming in with the errors that are happening, dependency failures, because we're depending on the web API, but the bug is in the web API. For a limit of 0, it goes bad. We can see the trace information coming in because we had the trace listener. And this is App Insights, but it can also do, well, the trace information, but it can also do the semantic logging, which I'll show in a moment. But this just flowed in free of charge just because we registered the trace listener, we registered the telemetry client, and this is what we get as a result. There's more things that we can see. The application map, for example, gives an overview of the entire application. And this is where you can see, and I'll zoom in a little bit, that this is the web API. The web API is calling a database, SQL Server here. It's using SAQ. It's doing calls to Azure.net for the Key Vault. Here's another thing with the client. We have tokens that we get for security, logging into Microsoft. And we can see that was one of the questions that you asked before. If I have performance problems, how can I find them? Well, I'll show you, because in this case, we're seeing, okay, there's a red flags, things are going bad. There's 6 calls here, and apparently with the red lights, things are not as good. So let's see what's there. And we can see, okay, there's failures and there's canceled. Let's have a look. Let's drill in. And then there's like, okay, 2 failures that are there. Okay, 2 dependencies here. Drill into the 2 dependencies or into the cancel event. And then this is what you get from all the information. Now let's say take the suggested one. Apparently this is good for investigating. And then here, this is where things get interesting. So I pressed F5 very fast, but here you can see the retries of 3 times. And if you want to see where am I actually slow, well, it's not that hard to find, because if you look at this web API call, it took really long. But if, and let's expand this a little bit like so, then you can see that the time that the database took is only 24 milliseconds. But apparently the call to the web API is 60 seconds. There's a bug in there that takes a lot of compute, but it's not the database. This is how you can find out that this took a long time. The database call is so small that you can't even see it. It's this little 2 dots here that make the database call. And you can see that the front end with our get to the home page had this exception of a socket. It's being terminated, a timeout, because it took too long. And we retry and we collect all these things. Apparently there was one call where the database was unreachable. And when retrying on the timeout, we had 3 retries. Well, this is what you can learn from this. App Insights also gives you this logs here. This is much like SAQ, where you can say, okay, so we have a trace, and I want to see where my custom dimensions. Let's see, I need to pick the. I hope this is normally you get the custom dimensions.search. Limit. Oh, there's actually one here. Let's just run this one. Get rid of this. Run it. You can see that you get all this information where we have a search limit bigger than 0 with all the things that we queried here. And we can even say smaller than 5, for example, and run it. And then you can see that there's a 0 and maybe some other values like the 3 we had here. And you can investigate them. And here you also have the same thing where your it should be something here, custom dimensions. Then you have your search limits right here, much like SAQ. This allows you to query all the logs with this information, the semantic logging, and even there's metrics that you can use. Metrics give you the ability to look into the system and look at, well, for example, the log-based metrics with availability and browser things. You can have Web Insight things with whatever memory, other things that you extract from your system. But most interestingly is where you do your own events. For example, if we use the API to register a high score, we're injecting a telemetry client object into the constructor of the other endpoint, the scores. This is where you can submit a new high score. And the post score method, that's right here, it does start a new activity with a gamer as tag, so you can enrich it. But down at the or at the bottom, at the top, you have this start operation, and at the bottom you can use this client to track events. There was a new high score because we got to the point we didn't return because the score wasn't high enough. We have a new high score; it's registered. You can send out metrics saying, okay, this is the value. And this might be something else than the actual high score. It might be the value of your shopping basket, something business relevant, because that might be really good to know. If you're having a closed sale, you can have events that says, okay, we closed the deal, we closed the deal. And if your system is still up and running, but all of a sudden all the sales per minute go to 0, it might be that your system isn't down, but it's not doing anything anymore. And that's another way of monitoring your system from a business perspective. Are we still in business instead of are we still up and running? Now these things, the high score and the new high score events, you can find them in the metrics, for example. If we go here and we look at the application insights, you can see that there's this high score, and it gives you a graph of the high score that is currently running. And if you submit a new high score, you can see the graph switching here. That's one thing. And the other thing is the events, where you can see, okay, there's a lot of events happening in the last 24 hours. This is where we started doing things, but you can filter that by saying, okay, I don't want to use all events, just custom events, and I want to see the new high score ones. And then you only get the new high score values. And you can see, okay, so at this point in time, we had a new high score submitted, and you can see the activities in your system from a eventing perspective. All right, closing up. 4 questions in a moment. What we talked about was making your system observable. We had the logging and tracing in place. We had the metrics and eventing that we send out. We had the health monitoring with health endpoints, with everything together, using a application performance monitoring tool. In this case, I demonstrated App Insights. You get most of the things for free because your system is observable, and you're just using the monitoring system to get the deep insights for troubleshooting, for investigating and doing your analytics. This is just the start of what you need to do to practice DevOps and really live DevOps. I hope you get a starting point from all of the things you've seen so far, and start using it, start digging deeper. There's much more to uncover. I barely scratched the surface, but I hope you can get a head start with instrumenting your application and doing proper DevOps. So if you have any questions, feel free to put them in the chat now. And if you have questions later on, you can reach me over Twitter or at my email address. But if you are going to enjoy the rest of your evening from now on in, thanks for joining. And all the other ones that want to ask questions, feel free to do so.
Hey again, Alex. We already have some questions, but I just want to start from thank you for your presentation.
Very welcome. Thanks for having me.
So do you remember we sent some questions form for participants, and there were a couple of questions from participants as well. And I would like to start from this one. I believe you gave some cases, but maybe you can frame it as a short answer. When a performance issue on Azure SQL database or app service, what is my roadmap to find a problem?
Yes, but this is, I think, what I tried to show in the demo, where you had your application map with all the dependencies and the flows of information, where you could just pinpoint what is actually happening, where are things slow, and you can investigate further. Mostly you're interested in where does it take very long, and then you start finding out which flows, which parts of the spider web that you saw are giving trouble, and that's one way of finding it. Then you can see, is my database slow, or is my app service running into memory limits? And where is the actual root cause for the performance issue? And in the demo, you could see that it's not the database, it's the app service that is having trouble. And then you find out that it was actually you making a programming error with a bug in your system.
Thank you. The other question is, Linux servers are cheaper than Windows. We want to move our project to Linux, but application insight does not exist in Linux server. We want application insight metrics. Can we collect all data with Microsoft Application Insights.NET library?
Okay, let me see if I understand the question correctly, because you said that its application insights is not available on Linux. Was that the question?
Yes, the participants say that application insight does not exist in Linux server, but maybe we can go to another question. And
no, I can answer it. The Linux server. Yes, okay. App Insights is a cloud service, so it doesn't run on your own machine. It's always running at Microsoft Azure. You can't run it on premises. It needs to be there. If your application itself is running on Windows, you can use your .NET code and you can run it there. But what I showed you today was actually all running from Linux. The applications were running in a container, which was a Linux base image, using Linux, Ubuntu, is that correct, or Alpine, one of the two. And the .NET Core libraries are cross-platform for application insights, and you can do that on Linux as well. You're not limited to Windows.
Great, thank you. The next question is CQ support the configuration to sampling messages? I believe there are two questions. And the other one is the health checker can use connection string instead of instrumental key for App Insights?
Okay, so the two questions. The SAQ support for sampling messages, I'm not really sure there if I understand, but if you want to do profile sampling, like every second I want to know certain metrics, then you need to look into other things. That's profiling, and that's has other things. You probably want to look into ETW for Windows or LTTNG for Linux. And in .NET 5, you have a new thing called Event Pipe. And Event Pipe is a way of your .NET tooling to connect with your application for tracing information and sampling. And there's a variety of sampling providers, and there's the sample profiler provider. If you run that inside of your application, you will get a periodical sample of information. Okay. Let me because apologies for my laptop crashing. This time it was my fault. The last question was yes, the health checker can use connection string. If you look at the Xabaril GitHub repo, that's a project that created many of the health check implementations. And it goes across Azure, across AWS and Google, and they have a variety of health checks that you can use. So connection strings for databases, but it can be Cosmos DB, MongoDB, or other things. And it can be your Key Vault or your Redis cache. They have so many implementations there. You should definitely check out Xabaril on GitHub, and they have all the documentation. And that's also where I showed you the health check UI, where that had the visualization of the health checks that were turned red. That's also from their making. In other words, define or find your dependencies and create health checks for them.
Thank you. So I believe last question, if no one drops anything else in the chat. I'm interested in the main new features in .NET 5, which makes it more handy for C# developers, migration details from another .NET Core application, and differences and new opportunities. We already talked with you that it's like a broad question and it needs like another session, but maybe you can answer this.
Yes, I think that some of the things you see in .NET 5 are tweaks for bringing everything together. And it's a natural evolution from .NET Core 3.1. That's the last .NET Core version. Well, for those who don't know, they skipped over .NET Core 4 because .NET Framework already had 4.8, and that would be confusing. So now 5 is the next new thing. I pointed out two particular things that are small details, like the simple console debug logger. That's one thing. And we had the event pipes in the mechanism of doing this new tooling for .NET Trace, .NET Dump, .NET Counters. You can look those up. Those are new tweaks to bring Windows and Linux even more together. And a lot of the things that happen in .NET 5 might not relate to special improvements for us cloud developers, but it's more performant. There's better support for gRPC, other things. You find it a logical evolution, and that's what's happening. I found that migrating my .NET Core 3 implementations to .NET 5 was as simple as redefining the target from .NET Core 3.1 to .NET 5.0. It got in the new SDKs. I had those installed, and most of the things just kept working. And some things are deprecated, but it's your Visual Studio tooling that will say, okay, this method that you're using now is deprecated. You should use this instead. That will help you do the migration. If you're on .NET Core, don't expect any very big changes to the way you need to build your application. If you're still on .NET Framework, however, then that's quite a big investment to move to .NET 5.
Thank you. There is another question. Wait. How to measure an impact to application performance of having all this login, trace, and metric stuff?
Okay. Yes. The performance implications. One of the things, if you start doing this, is that you need to think about what do I want to measure and what is performance. And it can be how fast is my response for an HTTP request. Performance can also be I'm using more memory, and so that might be bad for performance if I have more memory usage or more disk I/O than I had before. That you need to think of those things in advance, because there are so many things that you can see. I would suggest looking at metrics in this case, because performance is about metrics, not logging and tracing. Those are for record keeping and for following flow. So you go to the metrics, and the metrics come from your system. That's mostly the control plane and some of the resources that have the diagnostics information. It's where you might be sending out information to Prometheus or App Insights, collecting those things, combining it with your Azure resource information. And then you define, okay, I want to know if what the trend is in the response times, for example. That can also indicate that you're less available. But if you want to look at the trends there, then you can see average trends in per minute, for example, or per hour, per day, per week. And if you're talking about per week, that's where things get interesting, that if you release a new feature and you are measuring these things, and then right after releasing your new feature, the performance goes down. It performs better or worse, more longer response times. And that's when you can evaluate, did this new code make things better or worse? Or is there congestion in your system? That is for a current release. If there's a lot of requests coming and the rate of requests comes in, and you see that your database response times go very high, then you can find out the trends by analyzing. But it's watching the graphs. You can do I showed you the tracing information with the high score, but you can pick memory usage and then look at the graphs, create dashboards from it, and start monitoring those, defining alerts. If it goes below this, then we need an alert to have somebody look at it, because then there's something bad happening. That's what I would suggest. To measure impact, look at metrics, and start defining the things that you want to look at, because you need to choose.
Thank you. I believe that there was a specification of another question, but it was deleted, but maybe I can get it back. So is the health checker can use connection stink instead of up inside instrumental key? I guess there was a correction to the question.
Yes. Okay. Yeah. Well, this is where I said that the health check for the health monitoring in ASP.NET Core, it's a matter of defining which things determine my health. Is it a memory usage? Is it a resource like a web API that I need to call, or a database that I need to call, or Redis cache that needs to be available? And then you find the proper health check implementation. Xabaril was the place to look and Google for. And then you will find that they have, a lot of things from RavenDB to MongoDB for databases, SQL Server, and so on. Or cache implementations, Google, Azure, Amazon resources, they are all there. Cassandra, you name it, they have it. And then it's just a matter of adding Cassandra something, adding MongoDB something, and then you specify the details. And I hope that I understand the question correctly, because the instrument key for App Insight was just a secret inside of the Key Vault. An example, it's a demo, remember, that it needs to be there, otherwise it might not function. It could be a certificate, for example, in Azure Key Vault that has an expiry date and is no longer valid. Then you can see, my HTTPS, my SSL certificate is expired, so I can't provide HTTPS traffic to my website anymore. And it's bad when the customers tell you, but it's better when you yourself find out, next week my thing is going to expire. Then you can, ahead of time, your system says, okay, I'm degraded because in a week it will be invalid. That's how you proactively instrument your application, so you know before it happens that something might be happening.
Okay, great, thank you. There is another question as well. I put it in the screen right now. Differences with tracing in application versus per view. Do we need it?
Good one. That's one topic that I didn't cover. If you want to use per view, you need to have other type of trace information. It's not the one that we've used so far. There is a way to flush things to the event tracing for Windows, which is a high performance way of getting performance metrics and events into a system that you can log. You will get ETL files out of that most of the time when you inspect something. In .NET 5, which is new, you can use event source. I believe some parts were available in .NET Core 3, but they did more stuff with event pipes and other things to really bring this, because event tracing for Windows is what it sounds like. It's for Windows. It's not for Linux. If you want to use Purview, start looking at .NET Trace, which is a tool that you can install in your .NET command line. So you do .NET tool update trace, .NET Trace -G, and you run that and you install the facilities, and then you can connect to your application and hook into all this information, and you provide, or you specify which providers that you want to listen to, and then you find out that your application has already been instrumented with all these events like ASP.NET Core hosting, how much HTTP requests are we handling, how many did fail. That's already in that information. You don't have to do anything. There's about the .NET Core runtime, the core CLR, that has information as well, from garbage collection to allocated threads, congestion on your threads. That information is also being sent. You get it for free. And you might want to send out your own metrics there as well. If you have special cases, for example, if a web request happened, did we get a garbage collection or not? That's not available by default, but you can do your own logic and send out that information as event source. That's a new thing. And that will be collected into the system as well with .NET Trace. You can collect it, and with Purview, you can look at it. That's might be a topic for a new session.
Great. The next question, but it's not the question. Do you remember we had one question, then we had a specification, and this is one more, that Azure US Gov works only with connection string. Do you think you can comment something on this, or is it just a specific case and maybe it's better for participants to contact you? And
yes, Azure US Gov. Okay. Okay. So that's a very then I understand the question a bit better, I think. It might be that Azure US Gov is one of the special regions for sort of private Azure hosting. I believe China has those as well. Germany used to have them, and the US government might have it as well. So the person that asked the question, please reach out to me, because if there's limitations to the Azure offering for the US government, we might have to look at a different way of doing health checks. And if it's only connection string, that's still very well possible, because what I showed you was the DB context. But if you use the Xabaril one, they do work with the connection string. So there's a different SQL Server one that you only need to specify connection string, and that should be your connection into the Azure SQL. But okay, if that doesn't answer the question, my email address is in the slides, or reach out at my Twitter handle, Alex Thissen, and then I'll try to answer that as fast as possible.
Yeah, I sent your Twitter in the chat because someone was asking, so our participants can easily reach out to you if they still have questions.
Please do, yeah. Even if you're reading up on things or get some new insights, or have a great new implementation, do let me know, because I really would love to hear your questions and your ideas and your inventions. Yeah, please share.
Thank you, Alex.